Well, good afternoon, everyone. Today's the third session in the group of lectures on engineering, communication, language, presenting scientific information and writing technical reports. And it'll be a combination of what we covered in the previous two, where in the first one we reviewed language and communication in general. In the second one, you may recall, we looked at precision and accuracy and the differences. We looked at significant figures and also the norms and procedures for graphing. So with technical report writing, there are two documents that have been uploaded into the Moodle site, which along with the others you are encouraged to review, especially before you are writing a technical report, just to touch base with the main issues that you have to address or be aware of. This first document that I'm going to look at, and I'm going to look at it very briefly, as you can see, it's written by the Institution of Engineering and Technology UK, Guide to Technical Report Writing, is a bit more comprehensive than what you're going to need to know or be aware of as an undergraduate, but it's a beautiful document, and I say beautiful because it's very readable. It's a very good exemplar of a well-written technical document, or any document for that matter, and it will be something that it would be advisable for you to look at from time to time upon graduation when you are writing a longer report in the industry. Most reports like this one here have a contents page, and you can see that with contents pages the main, how can I put it, style is that the headings and subheadings stand out, that there's indents and there's a consistent use of numbering to distinguish headings and subheadings, and that is all about clarity. And it also indicates that at the back there are appendices and bibliographies. The introduction to this document states that a good report is easy to recognise. Its title is precise and informative. In other words, when you look at the title, you know exactly what the report's going to be about. Its layout and format are well organised, and the binding is easy to handle, opens flat to reveal both text and diagrams. It should be pleasurable. The style accurate, fluent and concise. So if you, as the reader, enjoy reading it, you'll be encouraged to take more note of it. You'll be interested in finding out more, and it will also convey the message a lot better because you are going to engage with it a lot better. Some of the features of a report, and a long report or a short one, is that the reader is the most important person, it meaning that if you're writing a report for your peers, your other colleagues in the workforce, it's going to have a different style, and the language will be also different, and also maybe the extent of it or the scope may differ compared to writing a report for management or for your senior discipline manager or team leader. The report as short as possible, don't put in more than what's required. Make it convenient to the reader, and also make it accurate, concise and unobtrusive. In other words, use the right language, use it correctly, make it say what it's meant to say, and don't clutter it with other things such as graphs and tables. Put them at the back in the appendix. There's other checklists that you can look at, but as I said, I just want to quickly overview it because it's the second one that's more specific to you as an undergraduate. So at the beginning of every report, you as the organiser of the report and the future writer have to work out what it is that you're going to be reporting on, what information you're going to have to gather so that you are focusing on the necessary and you're not extending beyond that. So the objectives have to be defined at the beginning. The objectives will be where you decide what it is that you're going to be researching, what it is that you're going to be writing on, where the information is going to be gained, and why you're doing it. Are you doing it for management? Are you doing it for your lecturer? Are you doing it for your peers as a delivery here, as a report that you're going to do as part of a project, which you will be doing as part of your undergraduate work? So defining the objective. It could be that you have been commissioned to check the let's say the air conditioning system here at Tonsley, and there's one part of the Tonsley campus that's getting a lot of cold air, and you want to research into that and work out how to upgrade the aircon or modify it. You need to work out what it is that you're going to do. You're not going to obviously research or design the aircon as a whole, but you're going to look at the design of just that particular part. So the scope of what you're going to cover will need to be defined right from the start in the objective. The reader is the most important. In other words, a report for management, a report for your lecturers, a report to your fellow students will be different. So you need to define that. The format of the report, the style, the way it's set out, the structure has to have a beginning, an introduction that defines exactly what it is that you're going to be writing about. The appendices is where you put the additional information so that someone can read through the report easily without having to stop and study a lot of figures and lab results or copious calculations. Keep the report as short as possible. In other words, work out when you're collecting information, you might have collected 5,000 words of information, work out what's essential, what's good if possible, and what you probably don't want to include that may be of interest to you but maybe not to the reader. So you need to distinguish between those three categories. All reports should have clearly defined sections and subsections. Usually the numbering will tell you. Section 2 part 3 will be the third part of section 2, etc. Quite often the numbering is indented and in lowercase. Headings and subheadings with decimal notation, I've already mentioned that. And the format or style of a long report is stated here. As I said to you before, this is more for the lengthy one, the 50-pager or the 20-pager, but for you, you probably won't need to worry about it. And the numbering system that I've already mentioned. References, when you are gaining information from somewhere, you need to acknowledge it. We at TAFE and the universities tend to favour the Harvard system. Any of you ever used the Harvard system of referencing? If you don't know what it is, TAFE has on their webpage access to the Harvard system. You can look at that or even print it off. But that's the preferred referencing system. Here, writing the report, okay, once you've got the information, it's now time to start writing. Take note of spelling. Take note of the fact that sometimes spell check won't get always pick up errors, even though you think, oh, I've got spell check, I'm not going to make a mistake, because Microsoft Office won't pick up the difference between the now and the not, because they're both correct words. So if you have accidentally, in your rush, typed now instead of not, the car is now in a safe condition to be driven, compared to the car is not in a safe condition to be driven, mean totally different things. Spell check won't pick it out. So even though you have used spell check, do read through it in case you hit the wrong key. New words, you need to, in a report, if you're using any words that are specific to your area that may not be commonly known, you should define them, explain the meaning, and make sure that you've also explained any symbols or prefixes. Punctuation, the use of commas, apostrophes, I've already talked about that in the first session, but once again, refer in the first session to the appendix, because it actually had quite a lot of examples of punctuation used rightly and incorrectly. Choice of words, don't try to, inflate your abilities by using big and highfalutin words when you can use a simpler word. So the idea is not necessarily to try to show off by looking up a synonym on the computer. Use the words that are most common if possible. Paragraphs and sentences. Try to have variety. Don't have all your sentences the same length because it looks very chunky. Try to vary it, some long, some short. Remember with paragraphs, what was one of the rules with a paragraph? Anyone remember from the first session? As well as the paragraph not being a whole page, that's not a paragraph. What was one of the rules? Try to keep the paragraph dealing with one topic. So you don't try to include 3 or 4 topics in the one paragraph because it will get too cumbersome. Brevity, get to the point. You know, sometimes at this present moment in time, just say now. Why try to complicate it? And there's lots of other examples. We once saw that. That could be okay if there's no improvement. Unobtrusive, don't clutter it with things that don't belong in that section. Don't clutter it with graphs and supporting information. There's a worked example here which I won't look at, showing you something written and errors in it. So when you look at this document on Moodle, you can have a read of this without looking at the errors and see if you can pick up the mistakes, because these are mistakes that are quite commonly made. And an improvement is there. Positioning, make sure that things are where to expect them. Don't have introductions at the back, don't have recommendations at the beginning. But also with positioning, it's important to try to put your annotated diagrams alongside your calculations. If you're doing any engineering calculations, you are required to do an annotated diagram. In other words, a figure sketching the data with arrows and whatever else. It's no good having the figure on the back page and the calculation on the first page, because the person who's checking your calcs has to flick back and forth looking at things. So try to have your diagram at the same place as your calculations. There are conventions and rules for doing things, and one of them is that we tend to read left to right, and the data should be in that order as well. Tables and graphs to illustrate supporting information. Where do we normally have them? At the back in the appendix. So you might set up one appendix, Appendix A tables, Appendix B graphs, Appendix C survey data, that sort of thing. And the other thing with it, of course, as well as them being in the appendix, is that you should cross-reference. So in your calculations, if you're referring to a table from an Australian standard, don't just say refer appendix, because the reader might have to flick through 20 pages looking for it. So say things such as Appendix A, Table 3, or something to that effect. That way it's clear. It's all about clarity. It's all about encouraging the reader to take note of things that are important, and referencing of diagrams and that as well. And finishing the report with a summary, conclusions, what are the main things that you've discovered are all very important, and an abstract. A summary and an abstract are different things. An abstract's a little bit like what you see when you are doing a search for a book in the library or online library, it could be. The short description of the book or the text or the movie or whatever it is that you're looking at is an abstract. It's usually written by someone else, whereas you, the author of the report, will be also writing the summary. Contents page and contents list. Now, I did try to do it fast, and checking things over, appearance, title pages, all this has been mentioned, and that's about all I really want to say. And of course, the fact that you have appendices at the end where you put the supporting data. Okay, so that's something worthwhile you looking at, especially upon graduation, so you can dump the PDF onto your computer and take it with you. It's the second document that I want to look at a bit more closely, because that's the one that will be used by you in the more immediate sense. So I'll just say the short technical report document that you see here has been produced by us here at TAFE, and it talks about the fact that your lecturer is the person who's going to access it, so obviously you need to make it readable by your lecturer. You don't want to be putting things in there that are obvious, or things that are of a technical level that the lecturer will already know. You know, you don't need to explain things that a lecturer will already know. Make it suit the level of understanding and knowledge that the lecturer would have. Try to use double spaces or space and a half. Try not to make your report too small. Make your font obviously one that's easy to read. You know, not like a size 9 Arial, maybe a size 11 or more, but depends on the font type. And supplement your material with various appendices. First of all, the same thing as the previous one, the objective. Define it at the beginning. Start off your report with a brief description of what it is you're doing your project on, or what your technical report's on. What's the scope? Is it going to be looking at the aircon upgrade of all the campus, or just one particular room? Is it going to look at just the wiring, or is it going to look at the plant and inverters? Is it going to look at just the flexi ducts? What exactly is it that it's covering? Because if you don't define that, the reader may be expecting more, or maybe even expecting less. So how you went about it. Did you do it by walking around in the ceiling? Did you do it just by looking at Google Maps? You know, because in both cases the level of data of where you've got your survey information will vary quite substantially. Why have you been doing it? Because, also, why are you doing it? Because it's part of your studies or because you've been commissioned to it. Make it brief, make it clear, make it concise. And then within the work, you'll have the various categories of the work that you've covered, the summary. Within that, try and identify any assumptions and restrictions. You've assumed, for example, that there'll be a constant supply of electricity and there'll be ample electrical supply for the upgrade. You may have assumed the restrictions may be imposed by the council to not allow a greater compressor or inverter that might service the building even better. So, you know, your assumptions, the restrictions on time, on councils and all that, if that is the case, of course, should be clearly defined. And at the end, always have conclusions and the results, what you have come up with. And it should all finish with recommendations. Where is this report leading? What is it that you are trying to achieve with it? Make it look like something that has been obviously well thought out because you are trying to impress the lecturer in this case. Now, most of your reports, well, not most of the reports, I shouldn't say most of your reports, but a fair few of them will have engineering calculations as part of them. And you are required to do engineering calculations in a format that is similar to what you'll be doing upon graduation in an engineering office. And as I've said to you before, engineering offices have their own pro formas or standard calculation sheets, usually with a grid, and they have a style that all the engineers or paraprofessionals work with and or adhere to, I should say. So grid paper, having every page labelled correctly with headings and subheadings, defining the units in any formula or equation that you're using correctly, having sketches with symbols and arrows pointing to the bit of the diagram that you're referring to. Any assumptions, you know, the assumption could be that it's being based only on rough measurement rather than any elaborate testing. It could be done by estimation. That could be an assumption rather than having done any accurate measurements. Highlight any intermediate answers with underlining or boxes. Where your data came from. It might come from an Australian standard, you know, which you will be dealing with, so you need to refer to the Australian standard. Simplify your calculations at the end. Try to keep the units correct. If you're referring to forces, forces have one unit. If you're referring to electric current, use the correct unit for electric current. Standardised dimensions and parts. You might be designing this air conditioning plant that I keep talking about for the upgrade in one of the rooms. You may have come up with a design of a certain compressor, but the standard ones available from retail are only you know, in multiples of 10 kilowatt, let's say. So you need at the end to come up with a design that you can actually purchase, not one that, you know, you can't get on the market. So standardised dimensions, standardised parts are very important. And the way calculations should look is a little bit like this. You have your grid paper, you have your heading and subheading and author and page number, and usually there are two columns on the side where you either write the standard reference, like could be AS 3600 clause 3.4, for example, if it's concrete design that you're doing, a diagram showing the data that you're using in your calc, that's representing a beam with forces on it, and the calculations with underlining of the main points. Okay, we're getting close to the end, folks. So what's at the end? This here is a check sheet that it would be advisable to print it off and use it when you are about to submit your technical report, just to flag things, just to look through and say, yep, I've done this, yep, I've done that. So look to see that you've included a description in your brief, in the introduction of what the brief, what you've been commissioned to do, what the objectives of the report are, that the body has calculations, that the units are correct, that you have references, that you finish with recommendations and conclusions, that you've had reference, if you have done any referencing, that you've correctly referenced it using some accepted system, and that you've included appendices and tables. A check the style, that you haven't rambled on, that you've used the language appropriate to engineering in this case, that you've done spell checks and that you've checked your punctuations and syntax, and that there's no green lines or blue lines or red lines produced by your Microsoft Word package, because that will obviously indicate that there are syntactical errors or grammatical errors. So this checklist, as I said, if you print it off and after you do the report go through and check the boxes, you will be a bit more confident that you've adhered to what the objective or the scope of the report was about. Now, what was I going to say? Oh yeah, that's right. The lecturers will also have in their mark scheme for projects and major reports a briefer condensed version of that, and they'll be using that to allocate marks. So in a report, the lecturer may allocate 5 marks for this and 2 marks for the other and 3 for something else. And obviously if you haven't adhered to it, you'll lose marks in those categories, but printing it off would help. And as I said to you before, both of those documents are in Moodle, so access them, have a read of them when you get a chance, and definitely look at them before you are doing a report to make sure that you're doing it correctly first time. All right, so thanks again for your attendance, and that concludes today's session.